All right, in this video, we're going to talk about linear differential equations. And a linear differential equation to us is going to be in the form of uh, a sub n dy dx. This is a real number coefficient here, plus, and then this is going to be p of x y is equal to f of x. And we can divide through by this coefficient. So let's just kind of ignore that right now and get it into this form. If we can get it into that form, then we can have an integrating factor mu of x is equal to e to the integral of p of x dx. It becomes something that's called an exact differential equation after that. More about that later, but let's just show you that if we would multiply through by this integrating factor, we would get something where the exact derivative of mu of x times y would be equal to mu of x times f of x on this side. And then we could say mu of x times y is equal to the integral of mu of x times f of x dx. If we do that integration, then we can divide by this mu of x over here and get our final answer. It'll become clearer as I do an example or two here, but I want to get it into that form so that I can find the integrating factor, and I'll just kind of use the inverse of the product rule without really showing it, and we'll talk about that a little bit more maybe when we have exact differential equations, because that's what we're doing there. So first problem here, dy dx is equal to 5y. So I want to rewrite that as dy dx minus 5y is equal to 0. So all my y things are on the left-hand side. My things without y's are on the right-hand side. So my p of x is going to be equal to a negative 5. So mu of x is equal to e to the integral of negative 5 dx. Mu of x is equal to e to a negative 5x. So this is going to be derivative with respect to x of e to the negative 5x times y is equal to 0 times e to the negative 5x. So that right-hand side is going to stay 0. And I'm going to have d dx equal to e to the negative 5x times y. So let's integrate both sides now with respect to x. And I get e to the negative 5x times y is equal to a constant over here, c, because the derivative of any constant was 0. So y is equal to c e to the 5x. All right, let's clear all that. Let's look at the next problem, dy dx plus y is equal to e to the 3x. So my p of x here is equal to 1 right there. So mu of x is equal to e to the integral of 1 dx, or e to the x. So d dx of e to the x times y is equal to e to the x times e to the 3x is e to the 4x. So e to the x times y is equal to the integral of e to the 4x dx. E to the x times y is 1/4 e to the 4x plus c, and y is equal to 1/4 e to the 3x plus c e to the negative x. Always try and solve for y. You should always be able to solve for y in these linear differential equations. Some of these related topics as we go on, they're related to linear, but they're nonlinear. You won't be able to solve for y. You'll have to solve for the other thing that you're substituting for. So the number 5 here, y prime plus 3x squared y is equal to x squared. So just write this as dy dx plus 3x squared y equals x squared to make it look like the other things we've been doing. P of x is equal to 3x squared. So my mu of x is equal to e to the integral of 3x squared dx. So that's going to be equal to e to the x cubed. And so this is going to be d dx of e to the x cubed times y is equal to x squared e to the x cubed. So e to the x cubed times y is equal to integral of x squared e to the x cubed dx. Going to multiply by 3 and 1/3. Since u is equal to x cubed, the derivative of x cubed is 3x squared. So e to the x cubed times y is equal to 1/3 e to the x cubed plus c. So y is equal to 1/3 plus c e to the negative x cubed. When I divide by e to the x cubed, that's going to bring it up as a negative exponent like that. Okay. X squared y prime plus xy equals 1. So I'm going to change that into y prime plus x to the negative first y is equal to x to the negative second dy dx plus 1 over xy is equal to 1 over x squared. My p of x is equal to 1 over x. My mu of x is equal to e to the integral of 1 over x dx is equal to e to the ln of x is equal to x. So we have d dx of x times y is equal to x times 1 over x squared. That's going to be 1 over x. So x times y is equal to integral 1 over x dx. X times y is equal to ln of the absolute value of x plus c, or I could write that as ln of c if I wanted to get the c inside of there, if that would be helpful. Let's go ahead and do that. Like that. So y equals ln of cx over x, something like that. X dy dx minus y equals x squared sine x. So dy dx minus 1 over xy equals x sine x. So we have p of x is equal to a negative 1 over x, and mu of x is equal to e integral of negative 1 over x dx. That's e equals u is equal to a negative ln of x. So e is equal to ln of 1 over x, and that's going to be 1 over x. So we're going to have over x times y dx is equal to 1 over x times x. Just gives me sine x on the side. So 1 over x times y is equal to integral sine x dx. It's going to give me 1 over x y is equal to a negative cosine x plus c, and y is equal to a negative x cosine x plus cx. Right? Let's look at a couple more here. X dy dx plus 4y is equal to x cubed minus x. So we want dy dx plus 4 over xy equals x squared minus 1. I haven't mentioned this yet, but it's just as likely that we're going to need to set this up as dx dy plus p of yx is equal to f of y, and get a mu of y instead of a mu of x. There's a couple problems like that, so don't think just because I can set up every problem as dy dx plus p of xy is equal to f of x, that's going to work that way every time. If you get stuck doing it that way, then go ahead and try and solve it the other way. So p of x here is 4 over x. Mu of x is e to the integral of 4 over x dx. It makes this e to the 4 ln of x is equal to e to the ln of x to the 4th is equal to x to the 4th. So this is x to the 4th times y. Derivative of that is equal to x to the 4th times x squared minus 1. It's derivative with respect to x of x to the 4th times y is equal to x to the 6th minus x to the 4th. So this is x to the 4th times y is equal to integral of x to the 6th minus x to the 4th dx. X to the 4th times y is 1/7 x to the 7th minus 1/5 x to the 5th plus c, and y is equal to 1/7 x to the 3rd minus 1/5 x plus c x to the negative 4th. All right, let's look at another one here. Squared y prime plus x times x plus 2y is equal to e to the x. We're going to divide by x squared here, and we get y prime is equal to plus x plus 2 over x equals 1 over x squared e to the x. So we're going to have y. So this is dy dx equals 1 plus 2 over x. Y equals x over x squared. So my p of x is equal to 1 plus 2 over x. My mu of x is equal to e to the integral of 1 plus 2 over x dx equal to e to the integral of dx plus the integral of 2 over x dx. So that is equal to e to the x plus 2 ln of x is equal to e to the x plus ln of x squared. So that equals e to the x times e to the ln of x squared is equal to x squared e to the x for my integrating factor. So we have d dx of x squared e to the x times y is equal to x squared e to the x times e to the x over x squared. The x squareds will cancel. And that leaves me with x squared e to the x y to the integral of e to the 2x dx. E to the x times e to the x is e to the x plus x is e to the 2x. So I need a 2 and a 1/2 to balance that out. So x squared e to the x times y is equal to 1/2 e to the 2x plus c. When we divide everything now by x squared e to the x, we get y is equal to 1/2 e, let's see, x to the negative second, e to the x, e to the 2x divided by e to the x is e to the x plus c, x to the negative second, e to the negative x. All right, I think that's probably enough of those for now. Again, there are some examples in here where you can find them where you'll have to solve for x as a function of y instead. So watch out for those, but I think that that's enough examples for you to see what's going on, where you find your integrating factor, multiply both sides by it, and you're taking the derivative of the left-hand side is exactly equal to that integrating factor times your function of x that was on your right-hand side. Then you integrate both sides and get rid of that integrating factor that was on the left-hand side by dividing by it and solve for y. Right, that's it for this video. We'll come back next time and we'll talk about exact differential equations. See you for the next video.